Hey everyone, in this video we'll be designing a web crawler. So before designing a web crawler, let's see what a web crawler is. So in a layman term, what a web crawler is, you must have used multiple search engines, right? So most popular, take an example of Google search engine. So when you type a query into the search engine, it goes and picks up a collection of web pages on which you can find the relevant information. And how it does that? It does this with the help of web crawlers. So what web crawlers does, web crawlers goes to the web pages, take the content, pick up the content, and then goes to another, like all the fetches all the URLs present in the content and goes again to those connected web pages and take the content and decide that whether that content is useful or not. So we'll basically gonna design how web crawler fetches the content from web pages and move ahead, right? So let me quickly write this up here. So in a high level, as the name suggests, web crawler. So basically it crawls the web, right? So how it does is that, so suppose we have a crawler here, right? We have a crawler program. What it does is that it goes to the web page, right? So suppose we we told the URL that we told the crawler that hey, goes to the web page with URL1. Then the crawler goes to the web page with the URL1, takes up the content here. So it pulls all the content of this web page, right? And now what it does is that it looks into the content, that whether there are another URLs or any other URL which is present in the content or not. If there are other URL, it goes to those URLs as well. So what it does is that it extracts the URLs from this content. So what it does that it gonna extract the list of URLs. So we can have, like, suppose URL1, URL11, URL12, URL13. So it's a basic naming convention, meaning that within the parent URL1 we found these three URLs. Okay, cool, perfect. I'm gonna just move this up. Yeah, this looks good. Okay, great. Yeah, so these are the child URLs which it went to. Okay, now what we can do is that now what a web crawler does, it again goes to these child URLs one by one. So from here it goes to URL11, URL12, and so forth and so on. And this process keeps on happening until it has exhausted the entire search space. So this is a basic design of a web crawler at a very high level, that this is what web crawler does. Now there is an interesting problem to solve here, is the problem of cycles. So let's explore this problem here. Just clear this up. Okay, so we have a problem of cycles, or we can call it a problem of loops. So what we do is that we try to avoid loops while traversing. So the crawler tries to avoid loops, otherwise it will be trapped in an infinite cycle. How it happens? It happens like this. So suppose we had a crawler which went to this URL, right? Now what happens is that this URL, the content of this URL has, or basically the content of the URL was pointing to three other URLs as well, right? So let's say URL2, URL3, and URL4. So this particular URL1 was pointing to these three URLs. Now what happened is that URL4 was also pointing to three URLs, which was URL5, URL6, and it was also pointing to the parent URL. It happens a lot of times. So suppose you have a home page, a website with a home page, right? You go to the home page, then from home page you went to another page, and that page directs back to home page as well. So it is very easy. It's very easy to find these cycles here, right? Let me pop this here. Okay. So yeah, it's very easy to move these cycles. So we have URL 5 and URL 6. So we can see that from the crawler can move from URL 1 to URL 4, and then from URL 4 to directly to URL 1. So this is a cycle here. This is what is happening, is that this is a cycle and we have to avoid that. And in order to avoid this cycle, we keep a storage, or we keep a shared storage. So what we do is that we keep a shared storage like map kind of structure. So suppose we have a shared storage. So what happens in shared storage is that once a crawler has visited a particular URL, it keeps that in the shared storage. So this is marked as crawled. URL1 is marked as crawled once the URL1 is crawled. Okay, then suppose it moves to URL4, it marks URL4 as crawled. Okay, now once it again goes back to URL1, then it sees that hey, we don't have to crawl this URL again because this has already been crawled, right? So it skips this. It do not crawl this URL because it has been already been crawled. And how it find this? It gonna find this with the help of the shared storage. So shared storage tells us that hey, this is the URL which has already been crawled, and don't need to, like, you don't have to crawl it again. So it is skipped, and the crawler can again move to the unvisited or uncrawled URLs like URL5, URL6, URL3, and URL2, right? And in this way, it keeps on searching or crawling through the search space until the entire space is exhausted, and it avoids crawling the already visited or already crawled URLs. Look around how a web crawler functions, right? How a web crawler crawls through the web pages and fetches the URL content, fetches the child URLs, and then goes again to those URLs. And we also discussed how it avoids cycle, right? How it's avoid recrawling the already crawled or already visited URL. Now what we will do is that we will discuss serial crawling. So in this episode, I'm gonna cover two ways in which we can implement a web crawler. One would be a serial crawling method, where we will have a single processor which will gonna crawl the entire web ecosystem. And the second method would be the distributed crawler. We'll call it a master worker architecture, where there will be multiple workers or multiple processors which will gonna crawl the multiple web pages or URLs parallelly. So let's first discuss serial crawling. Okay, serial crawling. So this serial crawling, the method, the code is very similar to a graph traversal or a recursive method. So if I have to write the code for it, so suppose I write a function, I call it serial crawler, right? So what we do is that we give a base URL to it, the URL from which the crawler will start crawling, and we will also have a map. This map is basically a shared map, right? So this shared map can have a URL, or like, we don't need to directly say it a URL, we can say it a string, because again URL is nothing but a string, right? So we will have a string and we will have a boolean saying that hey, whether this URL has been traversed or not. Okay, so this is a basic method. What should this method do? So the first thing this method will do is that it will gonna check that whether the URL which has been given to the serial crawler is already been crawled or not. And how it does that? We previously discussed that it checks the map basically. So it checks the shared map, whether that crawler, whether that URL is present in that shared map or not. So it will gonna check if our map, right? Oh, we have to give a name to the map, right? Just let me erase this. Let me write the name. Suppose the name of our map is crawler. Okay, cool. Now it will again check if this URL has been crawled or not. If this URL is crawled, then it will return, right? What we did here is that we are checking in the crawler map that whether the URL was present there or not. If the URL is already present, it means that that URL has already been crawled and we do not need to crawl that again. So we will return. Okay. So this is the if statement. Now, if this has not been crawled, we are planning to crawl it, then we need to mark it crawled. Okay. So if this has not been crawled, we will say that okay, although this URL has not been crawled, we are planning to crawl it now. So let's mark it already crawled and then we can start crawling this URL. Okay. How to crawl this URL? So there can be a method which will give us the content of this URL. So maybe we have an HTTP method that can take a URL and it can give all the content present in that URL, right? We have an HTTP method which gives us the content, and now what we can do is that with the given content we need to pull the URLs present in that content. How it can be done is that you can build your own child method for this using some string pattern matching technique to pull all the URLs present in the content. It could be a good problem to solve. You can like try writing your own method. Okay. So this method should give us a list of string, which we can call it URLs. We can call this method as get child URLs, and it takes the content and it gives all the URLs present in this. Okay. So now since we have the URLs, we need to iterate over those URLs to further crawl them, right? That's what we were doing. That's what we discuss in the high level design. So what we will do is that we will quickly child URL present in the URLs and we will perform a serial crawling on it. Let me erase this. Should be a crawler. Okay, so we should perform a serial crawling and then we return. So this at the high level, this is the method which it looks like, and we have two return statements, one here and another here. There are two ways in which it can return. Okay, so if this URL has not been crawled before, we went ahead, we marked this URL to be set to be crawled, and then we looped into the child URLs present in that content of the URL, and we are again serially crawling each and every URL. So suppose we have this serial method which was called for a URL named as URL1, and we can assume that we have a global storage which is map. Okay, so we are calling serial URL1, right? So what it does is that the serial method will check whether the URL was fetched or not. Now the URL has not been fetched before, so what we will do, we will put that in the map, right? So I'm just gonna remove it from here and put it below. Okay, let's assume that this is our shared map or a globally available map. So this map will be available to all the methods because it is global. So what we have to do is that since the map does not have URL1 and we are crawling URL1, we need to put that here. So URL1 is crawled, we put URL1 here with a true statement here. We have crawled this particular URL. Now what we can do is that suppose this URL now directs to 3 other URLs. So now what will happen is that serial method will again call each URL one by one, because what it does is that it gets the content of URL1, it extracted all the URLs present in the URL1 content. It got 3 URLs, now it's crawling child URL one by one. So suppose first URL which it got is URL2. It crawled URL2 and it put that in the map. Okay, it puts it in the map saying that hey, I have crawled URL2 to true. Cool. Now again in the similar way it can call URL 3. Okay, it crawls URL3 and again puts it in the map, in the shared map. So it says that hey, I have crawled URL3. Okay, now suppose if this URL1, suppose it doesn't crawl here, suppose URL2 moves or URL3 crawls back to URL1. here again we have a cycle. So the shared map, what the serial method, what it does is that we saw that in the first line of the serial method, it checks whether that URL is crawled already or not. So if it goes to URL1, it will check in the map that whether it's called or not, and it will see there from here that okay, URL1 is already called. It's the value of this method is already set to true. So this URL1 is already crawled. We don't need to crawl it again, and this method, the serial method, will return from that part and it will gonna stop. So that particular method will stop. This will gonna return from here, this will gonna return from here. Again, if if URL2 does not point to anything else, then this will also return, and finally the root will return. So this is a basic recursive calls. In this way the serial method will execute. We discussed the serial architecture or the serial crawling mechanism, right? So we saw that how we wrote a recursive algorithm or a recursive method where we were crawling the web page serially, right? A single processor was crawling. Now in this method, we will be using distributed architecture, or we will be using more than one machines to crawl the web ecosystem parallelly. So how it will happen? It will happen through a master worker architecture. So let's write this architecture name down. This is called master worker architecture. Okay. Now, what's good thing about this architecture is that it can be very helpful with with leveraging multiple machines, or by leveraging multiple processes in parallel, we can crawl the ecosystem parallelly or ecosystem more faster than the serial crawling method. What's the catch here is that, remember, we were getting a lot of URLs from a single URL. So suppose if we are crawling one URL and we got multiple child URLs, right? Suppose this is URL1, this is again URL2, this is URL3, and this is URL4. So master worker architecture says that I will not crawl this serially, I will crawl this parallelly. So what it does is that it can assign each of these URLs to individual workers, right? So workers can be W1, W2, W3, W4, right? And now what these workers can do is that these workers can crawl these URLs parallelly. They can extract the child URLs from it and they can put it in the shared channel, or we basically call it a shared resource or a shared channel, where from where again master can pick the URLs and it can again give those URLs to the worker, so that worker can again pull their child URLs, put in the share content, and this happens until and unless all the workers die. And workers die when we have exhausted the entire ecosystem or the search space. So at a high level, the architecture will look like this. Let me clear this up. Okay, so we will have a master, right? And there can be multiple workers. There can be multiple workers. What master can do is that master can provide the URLs to these workers to crawl upon, and then what workers can do, the workers can further pull the child URLs from the given URLs and put it in the shared channel. So let's say we have a shared channel here. There is a reason this is called shared channel, because this is available to all the masters and the workers. So it is basically available to the master and all the workers, because you see that all these workers can put their extracted URLs or the child URLs which they pulled into the shared channel, right? So this is the high level idea of the master worker architecture. And then what master can do, the master can again pull the URL from the shared channel and it can again pass on to the worker, and in this way the entire crawling mechanism happen in the master worker architecture. Now let's move on to the code part. So here we will explore two code pieces. First will be the master, how the master method functions, and the second would be the worker, how the worker method functions. Okay, so let's explore the master method first. Now, the master method will look somewhat like this. So the master method will first accept a shared channel. This is the shared channel which we discussed earlier, that will uh, available to all the workers and the master, and where workers will put the URLs, and the master can pull the URL from it. Okay, and we'll also have a global map. Let's again call this map as crawler. So this was similar to the map which we used before in the while discussing serial crawling method as well. Okay, now the first thing what the master does is that it waits for the shared channel. So what does this mean is that it will wait until we put some URL into the shared channel. So once there is a URL in the shared channel, this shared channel will notify the master that hey, there are some URLs which has been put, and you can fetch those URLs from me and you can start the crawling process. So that is the whole gist, that it waits for the shared channel. Okay, cool. Once the master is notified from the shared channel that it has a couple of URLs into it, then the master will go ahead and fetch those URLs. So we can call this fetch from channel, which will accept shared channel as an input and returns a list of URLs. Like whatever the URLs which were put into the shared channel, it will gonna extract all of them. Now, ideally, what it does is that it will gonna loop through all these child URLs, right? All the child URL which is present in the URLs, it will loop through it. So after looping, it will check whether these URLs are fetched or not, or whether these URLs are already crawled or not. So how it checks that? It checks that with the help of the shared map. So again, we will check the crawler. This is nothing but the shared map which is defined here, right? It checks in the shared map whether the child URL is present or not. If the child URL is already present, then it will skip this URL, or it will skip crawling this child URL. If this child URL is not present, then it will go ahead and it will crawl this URL. And before going ahead, it should mark this child URL to be crawled because we are starting the crawling process. So very similar. The child URL has been marked as true in the crawler. And now what it does is that it starts the worker. Now it gives this child URL to the worker with the shared channel. Along with the shared channel, it gives this to the worker. Let me reduce this a bit. Put it here. Reduce it more. Okay, it can't be reduced in this, so I'm just gonna move it here. Yeah, this looks better. Okay, cool. This is the worker. It fires the worker if this has not been crawled. So this is the basic if block. This ends the if block, and this is the wait and notify channel. Once everything is done, the master is executed completely. So what master is doing, the master is fetching these URLs and it is parallelly giving it to the workers. It is parallelly giving it to the worker so that it can crawl upon it. Now, as we discussed in the high level design, is what worker does. Worker is a very simple program. What it does is that it takes the child URL which is fed into it by the master. It will extract the content of the child URL, pull all the URLs present in the content of the child URL, and it will put that into the shared channel. Very simple. Now let's quickly see the code of the worker. So I hope this is clear. You can if you feel, you can pause and you can check how this entire thing is happening, analyze this code block, and we'll move into the worker piece. Let me clear this up. Okay, worker. So worker method is very simple. So you remember we previously called worker from the master method. So what it gave is that it gave a URL. The master gave the URL. Along with that, master gave a shared channel too. Okay, this is the basic worker method. What worker method does is that, remember we did this similar thing in the serial crawling as well. It will first pull the content. So suppose we have a string content, we can use an HTTP method to get the content from the URL, right? We use an HTTP method to get the content from the URL. Now again, you can use your own child method to extract child URLs from this string content. So again, a list of child URLs, get URLs from the content. So we pass the string content and we get the child URLs. Now what we can do is that, now what will happen, what we will do some things differently. Instead of crawling, which we did in the serial crawling, we will push these child URLs into the shared channel so that master can again pick that up from the shared channel, right, and can give it to the workers asynchronously or parallelly. And in this way, this entire architecture, this entire flow will happen in a distributed format. So let's quickly write it down. We're gonna push this to the shared channel, right? These are the child URLs and this is the shared channel. Okay, this is the method. We push this to the shared channel. All the child URLs, we push them to the shared channel, and as soon as these child URLs are pushed to the shared channel will notify. We remember we had the wait and notify method in the master code block. So the shared channel will notify the master that, hey, there are some child URLs which has been put into me by the worker. Please extract them. Now again, the master will extract those URLs and further give it to the worker so that they can be crawled upon. So this is a very detailed structure of a master worker architecture. So I hope this system design episode on designing a web crawler was informative. If you found this session informative, then do like the video, subscribe to the channel, and if you want me to discuss more design cases or code walkthrough of these complex design cases, right, you can comment it down or you can ping me, you can DM me on LinkedIn as well if you want me to cover any other design cases apart from it. I'll continue to bring more design concepts and system design content on this channel related to multiple complex systems and machines.